friends, many a times children found that what is meant by factors and what is meant by multiples. They are having a doubt definitely about this. What is meant by factors and what is meant by multiples. So first of all, let us know what is meant by factors. Well, I have written one multiplication over here. 4 multiplied by 3 is equal to 12. Even 2 multiplied by 6 is equal to 12. Now, what is a multiplication? Multiplication is nothing but the repetitive addition. For example, when I said that 4 is multiplied with the 3, means I am, see, 1, 2, 3, 4. I am going to take 4 blocks for 3 times. So, 1, 2, 3, 4. This is repeated for 1, 2, 3. Now, it will, if I count for a total number of blocks, there will be 12 blocks. Even in this case, multiplied by 6, where I am taking a repetitive addition of 2 blocks for 6 times. In this case, we say 4 as the multiplicand and 3 as a multiplier. The number which we multiply a number is said as a multiplier. So 4 is a multiplicand, 3 is a multiplier. 2 is a multiplicand, 6 is a multiplier. But do you know that whenever I multiply 4 with a 3, I will definitely land at an answer as a 12. Or whenever I multiply 2 with 6, means I take 2 repetitive for 6 times. 2 is added for 6 times. So 2, when I take it for 6 times, I will definitely land at an answer of 12. So, many a times, these 4 and 3, they are known as the factors of 12 because they are making this fact that whenever I take a 4 for 3 times, I will definitely get 12. Or whenever when I take 2 for 6 times, I will definitely get 12. So from these blocks, it will be clear that 4 and 3 are known as factors of 12. 2 and 6, they are also known as the factors of 12. You can take like this way also. If I repeat 3 for 4 times, 1 3, second 3, third 3 or fourth 3. So if I change the position of 3 and 4, then also it will not change the multiplication. See, 3 blocks, 3 blocks, 3 blocks, 3 blocks. Entirely, they are making 12 blocks. Even if I take that 6 blocks, if I multiply 6 with the 2, for example, if I take 6 blocks and if I take 6 block double, 6 and 6, it makes 12. So, 4 and 3, they are also known as the factors of 12, and 2 and 6 are also known as the factors of 12. Now, what happens if I take one block for 12 times? One block for 12 times. So 1, 2, 3. This happens to be 12 times. Means 1 is multiplied with a 12. Definitely I will get 12 blocks over here. A line of 12 blocks. So you may say that 12 blocks are taken for 1 time or 1 block is taken for 12 times. So in short, what we got is 4, 3, 1, 12, 2 and 6 are the factors of 12. Now, if I give an example, say 15. Now, I know that if I take 1 block for 15 times, I will get 15 blocks. Or if I take 3 blocks for 5 times, I will again get 15 blocks. So here in this case, 1, 15, 3 and 5 are said as the factors of 15. Now we will go for next concept to find the factors of given number. Let us take an example of a number, say 36. Now, to find the factors of 36, we will start with dividing 36 by 1. So if I divide 36 by 1, I will get 36. Okay, let's try to divide 36 by 2. If I divide 36 by 2, naturally there is a 6 at one's place. So the number is divisible by 2. So I will get 18. Now if I try to divide 36 with 3, yes, definitely I can divide 36 by 3 and what I get is 12. Well, if I try to divide 36 by 4, you know that 4 9s are 36. So I will get quotient as 9. What will be the remainders in these cases? Remainders in these cases are 0. Remainders in these cases are 0. So what is mean by factors? Factors are nothing but the exact or perfect divisors of a number. Now let us try to divide 36 by 5. 36 divided by 5. So if I carry out division by regular method, I will find that 5 7s are 35 and we will get the remainder as 1. We will get the remainder as 1. So can you perfectly or exactly divide 36 by 5? No. So 5 cannot be said as a factor of 36. Okay, let's go for 6. I know that 36 can be divided by 6 and 6 are 36. So when I divide 36 by 6, I will land at an answer of 6. Well, can 36 be exactly divided by 7? Let us do this. 36 is divided by 7. 7 5s are 35 again. And what remains is 1. In this case also we are getting the remainder as 1. So 7 is not an exact or perfect divisor of 36 and cannot be said as a factor of 36. Now what about 8? Can we divide 36 by 8? Let us try this. 8. We are dividing 36 by 8. Okay. 4s are 32. So 8 4s are 32. What is the remainder in this case? Remainder in this case is a 4. And we cannot completely divide the given number by 8. So 8 cannot be said as a factor of 36. Well, what about 9? I know that the 9 4s are 36. So we can divide 36 by 9. And what will be the quotient? Quotient will be 4. And what will be the remainder? Remainder will be 0. No remainder will be at all. Now we will stop here. Why we will stop here is that I know that 36 can be divided by 9 and I get 4. On the other hand, when I divide 36 by 4, I get the quotient as 9. Okay, what will be the next number possible that can divide 36? Is it 10? No. For a number to be divisible by 10, one's place digit should be 0. Well, we will try to divide this 36 by 11. So for doing this, I am going to divide 36 by 11. So 36 divided by 11, 11 3s are 33 and what we get as a remainder as 3. So we got the remainder as 3. So 11 is not the exact or perfect divisor of 36. So we cannot include that in factors. As we have initially seen that by taking the 4 blocks for 3 times or taking 3 blocks for 4 times we get 12. And the same way, how many 11 blocks and for how many times shall I take so that I will get 36? No. After taking 11 blocks for 3 times or 3 blocks for 11 times, I will lead at 33 blocks and we need 3 more additional blocks for 36. So 11 cannot divide 36 exactly and cannot be said as a factor of 36. What about 12? I know that 12 3s are 36. So if I divide 36 by 12, remainder will be definitely 0. So 36 divided by 12. The answer is 3. But you can see that on the other hand, when 36 is divided by 3, I will get a quotient as 12. Same thing will happen if I divide. Okay, now let us find out any other number that can divide 36 completely? 13? No. What about 14? Is the 36 is in the table of 14? No. Is it in the table of 15? No. Is it in the table of 16? No. Is it in the table of 17? No. Is it in the table of 18? Yes. 18 twos are 36. But already we have got the result that when I take the division of 36 and 2, the quotient will be 18. So on the other hand, I can write the multiplication facts for all these division facts. If we start to write a multiplication fact for this division, I will write that 1 multiplied by 36 will be 36. 1 multiplied by 36, what I get is the 36. Okay, fine. One fact. When I multiply 2 with the 18 or 18 with the 2, I will get 36. 2 for 18 times, I will get 36. Next, 3 for 12 times, I will get 36. 3 multiplied by 12 as 36. 4 for 9 times, what I will get? 4 for 9 times, I will get again 36. Okay, now 6 for 6 times, again I will get 36. Okay, now if I go for the next thing, that I will take 9 for 4 times. 9 for 4 times. Is it 36? Yes. But can you see the here that 4 is multiplied with a 9 and I will get 36. Means if I take 4 for 9 times, I will get 36. As multiplication is commutative, means we can change the position of the numbers from first to second and second to first. So if I change the position of 9 and 4, will the multiplication will change? So if I take 9 for 4 times, the answer will change? No, this will not happen. Same is the case where if I take, instead of 3 for 12 times, I take 12 for 3 times, whether the multiplication will change? No. So here we got the factors of 36. So what are the factors of 36? Factors of 36 are 1, 36, 2, 18, 3, 12, 4, 9, and we will take 6 as 6 already there. So only 1, 36, 2, 18, 3, 12, 4, 9 and 6 are the factors of 36. So it's very clear. So if I said, write down the list of all the factors of 36, what already I told you is the factor means a number which divides the given number exactly. So I can find that 1 can divide 36 exactly, 2 for 36 is for exactly, even 3 can divide 36 exactly, 4 also, 6 also, even 9 can divide 36 completely without leaving any remainder. What about 12? Yes. What about 18? Yes. What about 36? Yes. So we find that if I jot down the list of factors of 36, I said write down the factors of 36. So I will make factors of 36 as 1, 2, 3, 4, 6. Then we will go for 9. Then we are having 12, 18 and 36. 12, 18 and 36. One thing to be noted over here is that the number 36 divides itself and will give the quotient as 1. So number is a factor of itself. So number is said to be the factor of itself. Now, we will find out the factors of some more numbers and we will discuss about the factors again in detail, and we will find out what are the different things about the factor. Let us find the factors of say 25. So I said that factors of 25. So first of all, we will begin with dividing the given number with 1. What I get is the same number. So first thing first is that I can divide every number with 1. So 1 is said to be the factor of every number. Factor. I can divide every number by 1. So 1 is a factor of every number. Fine, very good. So keep in mind. Now we will try to divide 25 by 2. For a number to be divisible by 2, one's place digit should be even. Means it should be either 0, 2, 4, 6 or 8. In this case, it is 5 and this number is not divisible by 2. For a number to be divisible by 3, we first of all take the addition of digits and see that whether the number is divisible by 3. Means 5 plus 2. 5 plus 2 is 7 and 7 cannot be divided by 3. So the number is not divisible by 3. Now we will take the 4. We will take the multiplication table of 4. 4 6 are 24 and 4 7s are 28. So what is about the 4 6 are 4 24 and 28? Where is 25 then? So there is no 25 in the table of 4. So what to do? We'll go for 5 now. Yes, we are having 25 in the table of 5. 5 5s are 25. No. Is there any number which can divide 25 again? We'll go for 6. As the number is not divisible by both 2 and 3, the number is not divisible by 6. Whether 25 is in a table of 7? No. 7 4s are 28. We are having directly 28. Okay. Now, or 27 3s are 21, 7 4s are 28. Whether it can be divided by 8, it is in table of 8, no. In the table of 9, no. In the table of 10, no. So, any other number after 10, you try it. You'll find that there is no other number which can divide the 25 except 25. So, what is the next number that can divide 25 exactly is 25 itself. So, we again land at the fact that a number is a perfect divisor of the number itself, and we will get as the quotient as 1. So what I will write now the multiplication facts for this division facts. So 1 multiplied by 25. 1 I have taken 25 times, I will get 25. Okay, if I take 5 for 5 times, I will get 25. And if I take 25 for 1 times, again I will get 25. So, what are the factors of 25 then? The factors are 1, 5, 5 we are already having over here, and 25. So, we are having 3 factors for 25, that is 1, 5 and 25. You can see that 1 is also here in the factor of 36, 1 is also here in the factor of 25. So, we can conclude that 1 is a factor of every number. We can prove by taking the next example. I said that find the factors of 37. So let us find the factors of 37. Okay. So first thing first, I will divide the given number with 1 because I can easily divide any number by 1 and I will get the quotient as the same number. So 37 divided by 1, I get 37. What about the divisibility by 2? The ones place digit is not an even number, so it's not divisible by 2. Okay, we'll take the addition of 3 and 7, it will be 10. And 10 cannot be divided by 3. That's why the number is not divisible by 3. 6 6 are 36. 6 7 are 42. So from 36 we are directly going to the 42. We are not having 37 in a table of 6. Even not in table of 7. We don't have 37. Not in table of 8. Not in table of 9. Not in the table of 10. 11 also. 12 also. 13. 13 2s are 26. 13 3s are 39. So we don't have number 37 in all other numbers. If you go for trying to divide 37 even for numbers between 11 to 20, you will not find any number that can divide 37 exactly without leaving any remainder. Let us try to divide 37 by 20. So 37, whether it is divisible by 20, 21 are 20, what remains is 17. So remainder is there. So 20 is also not a perfect divisor of 37. Then what is the number that can divide 37? Which is the next number? Well, the 37, if you try it 37 can be divided by 37 itself, and we will get the quotient as 1. Now we will write down the multiplication fact for these division facts. We can write that 1 when taken for 37 times, I will get 37, or when 37 is taken for 1 times, I will get 1. I will get 37. So clearly 1 and 37 are the only two factors of this number 37. 1 and 37. We find only two factors of 37, which are 1 and 37, and it will clear that 1 is a factor of every number. Okay, we'll go for one more example and try to find out the factors, and later we will go for what is meant by multiples. Let us try to find out the factors of 120. So we are having factors of 120. First thing first, we will try to divide 120 by 1. Yes, it can be easily divisible, and the quotient is 120, number itself. Well, 120 can be divided by 2 also, because we are having 0 at ones place. So I will get the answer as 60. Now when the 120 is divided by 3, I know that 3 4s are 12. So we get the answer as 40. And when 120 is divided by 4, what I get as answer as 30. When 120 is divided by 4, we will get the answer as 30. Can we divide 120 by 5? Yes, 120 can be divided by 5 because there is 0 at ones place. So 5 2s are 10, 5 4s are 20. So question is 24. What about 6? Can 120 be divided by 6? Yes, 120 be divided by 6, and the quotient will be 20. Let us try to divide 120 by 7. Is it possible? See, try it. No, 120 is not divisible by 7. Well, we'll try it then for 8. Yes, I can divide 120 by 8. And when 120 is divided by 8, 8 1s are 8 and 8 5s are 40. We will get quotient as 50. We will go to divide 120 by 9. And we find that 120 cannot be divided by 9. For a divisibility by 9, we'll take first of all addition of all the digits in the number, and we will see that whether that number is divisible by 9. So 1 plus 2 is 3, and 3 is not in the table of 9. So this 120 is not divisible by 9. So this is one thing. Okay, so we will try to divide 120 by 10. Easily it's 0 at ones place, and we find that 120 can be divided by 10, and what we get answer as 12. Okay, so we will go for next number which can divide 120. Well, 120 will try to divide by 11, and it is not possible. We cannot divide 120 completely by 11. We will get some remainder. What about 12? I know that the 12 tens are 120. Okay. Now one thing you will be observed up till yet, what the problems we have solved is that if I start multiplying these last two numbers, the quotient and the divisor, quotient and divisor, it will give me the multiplication fact and will give the factors of 120. Now 6, when it is divides 120, I will get 20. When I come to the division of 120 by 10, I will get 12. And when I divide 12 by when I divide 120 by 12, I will get 10. So very one thing clear is that here again the numbers are repetitive. So if I take now next number which can divide 120 is 15, and 15 8s are 120. 15 8s are 120. Next number which can divide 120 is 20, and 26 are. No other numbers between 12 or 15 or 15 or 20 can divide the 120 exactly without leaving any remainder. So we will stop here, and what we got is all the perfect divisors of 120. Which are those? Let us circle them. We are having perfect divisors as 1, 2, 3, 4 and 5, 6, 8, 10. Now We can see that 10 is also here, 10 is also here. So we can go for 12, 15, 20, 24, 30, 40, 60 and 120. So all these are the perfect divisors or the factors of 120. So we'll list down the factors of 120 as 1, 2, 3, 4, 5, 6, 8, 10, 12. Then we are having 15. Then we are having 20, 24, 30. Then we are having 40. Then we are having 60. And we are having 120. Now we are having a large list of factors of 120. Well, this is the major thing, that why we are divided a circle into 360 equal parts, and one part we are taking as a 1 degree for a measurement of angles. Even we are having 360 longitudes on the surface of the earth. We assume that there are 360 longitudes on the globe or surface of the earth, because we can make many more equal number of parts. We can divide 360 with a wide range of numbers into equal parts. See, all these numbers, they are saying that we are going to divide 120 exactly in the equal parts, without leaving any remainder. We are not keeping any remainder behind. That's why they are known as the factors of this number. So it's very clear that the factors are all the numbers which divide the given number exactly without leaving any remainder. If any remainder is left, then it cannot be said as a factor of that number. Now let us go for multiple. What is meant by multiples? Well, from the first standard itself, we are actually saying we are writing the tables of different numbers. Take an example of say 9. I want to write the table of 9. I write 9 ones are 9, 9 twos are 18, 9 threes are 27, 9 fours are 36, and so on. We are writing up to 10 also. Can I take 9 11s also? Yes, 9 11s. We are just for convenience, we are writing table up to 10 only. Actually, we can take 9 11s. 9 11s will be 99. Can I take 9 12s? Yes, why not? We can take 9 12s, 108. So we find that when a number is multiplied by any other number, for example, 1, 2, 3, 4, and so on, we will get the answer as 9, 18, 27, 36. These are known as the products, or these are directly known as the multiples of 9. So I said that 9, 18, 27 and 36 are first 4 multiples of 9. If I said find first 5 multiples of 12, then I will write that the 12 ones are 12, 12 twos are 24, 12 threes are 36, 12 fours are 48, and 12 fives are 60. Now these are the first 5 multiples of 12. So what are the multiples? Multiples are nothing but the multiplication table of a number. So you may be asked that first find the first 5 multiples of a particular number, might be first 10 multiples of a particular number. So don't worry about it. Just we are multiplying the number with 1 to 10 and we are getting the multiples of that number. So multiplication table gives the multiples of that number. So the concept of multiples is that much easy. Now we'll find the use of these factors and multiples in our daily life, how they are going to help. Okay, in next session.